All right, welcome everyone. This is part one of section 12.5. These are notes on the identity matrix. And what we want to be able to do today is be able to find the determinant and inverse matrix and be able to explain how to solve for the identity matrix and the determinant, which are somewhat tricky concepts. But if you just stick to the math, you'll be able to work through it pretty well. First, we want to look at an identity matrix. An identity matrix is, what if we're multiplying by 1? And what we mean by that is if we have a matrix like this, 1, 0, 0, 1, which is very similar to what we would see in binary code with computer programming. So this does have applications in that area. Or maybe 1, 0, 0, 0, 1, 0, 0, 0, 1. Notice that each row has the one place over from where it was in the last row. Okay, and we could keep doing this for a 4x4 matrix or a 5x5 matrix. And so now if we look at this example here, if we take this 2x2 matrix, okay, this is a 2x2, and technically this is a 2x2. If we take this matrix 4, 3, 2, 1, and multiply it by 1, 0, 0, 1, what we actually get is 4, 3, 2, 1. We actually get the exact same matrix that we started with. And that would happen if we were to take, say, this 3x3 matrix with ones in it and multiply it by another 3x3 matrix that has some numbers. We would get those same numbers again. And if we went through and did all the calculations, so if I took this row times that column and added it, this row times that column, this row times that column, and that column, we would get 4, 3, 2, and 1. It all works out, like the math works. But if we see this situation, we really don't have to go to all that trouble to work out all those individual multiplication and addition problems. We just know that it's going to be this same matrix. So that's an identity matrix. Okay. Next, we want to look at inverse matrix. So inverse matrix is kind of a tricky situation, but what we're talking about is if we took a matrix, let's say this is matrix B, and we take the inverse of it, okay? And if you notice on a calculator, there's an inverse button. It's not the same as taking it to the -1 power. It's a little bit different than that. And what the inverse of a matrix is if we took the matrix itself, so if this was the matrix, and we multiplied it by 1 over this, which is the determinant. Okay, so this is the determinant. And the way we calculate the determinant is we take A times D. And what I mean by A times D is this A and this D. So this first position and this fourth position. And then we subtract it from B times C, which would be these two values. Okay, so we want to know what this would look like in an example. So let's look at this first example and see how this works out. So we want to find the determinant of this matrix, -2, 2, 2, and 2. So again, we apply this idea of A times D minus B times C, and what we get is we're going to get 2 times, and when we talk about these, we say that this would be A, and this is B, this is C, and this is D. So what that means, we're going to have -2 times 2, okay, A times D, minus B times C, which is 2 times 2. And what we notice there is -2 times 2 is -4. 2 times 2 is 4, so -4. So the determinant here is going to be -8. And in the next video, we're going to use this. We're going to find the inverse of a matrix. And we're going to use this determinant to find that inverse.